In this section, we will talk about the DMVPN Fundamentals. Dynamic Multipoint Virtual Private Network (DMVPN) is a Cisco solution that provides a scalable VPN architecture. DMVPN uses Generic Routing Encapsulation (GRE) for tunneling, Next Hop Resolution Protocol (NHRP) for on-demand forwarding and mapping information, and IPsec to provide a secure overlay network to address the deficiencies of site-to-site VPN tunnels while providing full mesh connectivity. DMVPN was released in 3 phases, and each phase was built on the previous one with additional functions, guys. All 3 phases of DMVPN need only one tunnel interface on a router, and the DMVPN network size should accommodate all the endpoints associated to that tunnel network. DMVPN spokes can use DHCP or static addressing for the transport and overlay networks. They locate the other spokes' IP addresses, protocols, and MBMA through NHRP, which we will introduce after a few slides. Let's check the DMVPN Phase 1 first. DMVPN Phase 1 was the first DMVPN implementation and provides a zero-touch deployment for VPN sites. VPN tunnels are created only between spoke and hub sites. Traffic between spokes must traverse the hub to reach the other spoke. This is a legacy implementation of DMVPN. You can see in the phase 1 we have DMVPN hub, DMVPN spoke 1, and the DMVPN spoke 2. And tunnels are just between hub and the spoke. So if one spoke, let's say that if spoke 1 wants to communicate with spoke 2, the traffic should go to hub and then just forward it to spoke 2. When it comes to DMVPN Phase 2, it provides additional capability from DMVPN Phase 1 and allows spoke-to-spoke communication on a dynamic basis by creating on-demand VPN tunnels between the spoke devices. DMVPN Phase 2 does not allow summarization. As a result, it also does not support spoke-to-spoke communication between different DMVPN networks. This is also a legacy implementation of DMVPN. So on DMVPN Phase 2, we again have spoke-to-hub tunnels. You can see in here we can have this one, but spoke-to-spoke tunnels are also in here. So if spoke 1 wants to communicate with spoke 2, the traffic does not have to go to over the hub this time. So these guys can communicate each other by using the dynamically created spoke-to-spoke tunnel. When it comes to DMVPN Phase 3, this one refines spoke-to-spoke connectivity by enhancing the NHRP messaging and interacting with the routing table. With DMVPN Phase 3, the hub sends an NHRP redirect message to the spoke that originated the packet flow. The NHRP redirect message provides the necessary information so that the originator spoke can initiate a resolution of the destination network. In DMVPN Phase 3, guys, NHRP installs paths in the routing table for the shortcut it creates. NHRP shortcuts modify the next hop entry for existing routes or add a more explicit route entry to the routing table. Because NHRP shortcuts install more explicit routes in the routing table, DMVPN Phase 3 supports summarization of networks at the hub while providing optimal routing between spoke routers. NHRP shortcuts allow a hierarchical tree topology so that a regional hub is responsible for managing NHRP traffic and subnets within that region, but the spoke-to-spoke tunnels can be established outside the region. So, the figure on the screen illustrates the differences in traffic patterns for all three DMVPN phases. All three modules support direct spoke-to-hub communication as shown by Router 1 and Router 2. And the figure on the screen illustrates the difference in traffic patterns between Phase 2 and Phase 3 DMVPN with hierarchical topologies. In this two-tier hierarchical design, Router 2 is the hub for the DMVPN Tunnel 20 and Router 3 is the hub for DMVPN Tunnel 30. You can see in here we have Router 2, and that is the hub for DMVPN Tunnel 20. And we have Router 3, and that is the hub for DMVPN Tunnel 30. And in here, connectivity between DMVPN Tunnels 20 and 30 is established by DMVPN Tunnel 10. In here, you can see here we have the DMVPN Tunnel 10. And connectivity is over this tunnel between these different tunnels. For Phase 2 DMVPN tunnels, traffic from Router 5, you can see in here, must flow to the hub Router 2, okay, and it is sent to Router 3 on this direction, and it is just forwarded to Router 6. But for Phase 3 DMVPN tunnels, a spoke-to-spoke tunnel is established between Router 5 and Router 6, as you can see in here. And the two routers can communicate directly. So when it comes to the benefits of using the DMVPN, the first benefit is the zero-touch provisioning. DMVPN hubs do not require additional configuration when additional spokes are added, guys. So DMVPN spokes can use a templated tunnel configuration. The second benefit is the scalable deployment. Minimal peering and minimal permanent state on spoke routers allow for massive scale. Network scale is not limited by device. And the other benefit is spoke-to-spoke tunnels, surely. DMVPN provides full mesh connectivity while configuring only the initial spoke-to-hub tunnel. Dynamic spoke-to-spoke tunnels are created and as needed and torn down when no longer needed. There is no packet loss while building dynamic on-demand spoke-to-spoke tunnels after the initial spoke-to-hub tunnels are established. A spoke maintains forwarding states only for spokes with which it is communicating, guys. And the other advantage is flexible network topologies. DMVPN operation does not make any rigid assumptions about either the control plane or data plane overlay topologies. The DMVPN control plane is used in a highly distributed and resilient model that allows massive scale and avoids a single point of failure or congestion. At the other extreme, it is also used in a centralized model for a single point of control. And another advantage is multi-protocol and the multicast support. DMVPN, guys, supports IPv4, IPv6, and MPLS as the overlay or transport network protocol, and it also allows multicast traffic to flow on the other tunnel interfaces.